శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ 2008 లో స్థాపించిన కళాశాలలో ఎంబీఏ, నాక్ ఏ గ్రేడ్ మరియు ఐఎస్ఓ సర్టిఫికేషన్ సాధించిన మొట్టమొదటి కళాశాల శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ త్వరలో అటానమస్ కాబోతోంది.
2014లో ఐఎస్ఓ గుర్తింపు, 2015లో రాష్ట్ర ప్రభుత్వంచే ఏ గ్రేడ్, 2016లో నాక్ ఏ గ్రేడ్, ఇప్పుడు ఎన్బీఏ సాధించిన సంస్థ శ్రీ ముత్తవరపు వెంకటేశ్వర.
Hi everyone, I am Vijay, Assistant Professor of EEE Department, and going to explain about Power Systems 2, which comes in 3.1. So this Power System 2 will deals with the transmission, basically the transmission parameters. Means transmission parameters means resistance, inductance, capacitance, how it will affect the transmission and how we can reduce the transmission losses by minimizing the effects. So first of all, unit 1 deals with the transmission line parameters. As I said, it will deals with the resistance, capacitance, inductance for single phase, 3 phase, for symmetrical and unsymmetrical lines. So this is the syllabus of unit 1, which will comes to touch the types of conductors, calculation of solid conductors, calculation of inductance for 3 phase, single phase, and single line, double circuit line, concept of GMR and GMD, symmetrical, asymmetrical conductors, with and without transposition, bundle conductors, and calculation of capacitance with the effect of ground and without the effect of ground. Before going to the topic, we have to recall that transmission lines will be used to transmit the power from source to distribution, because the generating stations are located at remote places and load centers are away from the generating stations. So we need to supply the output of generating station to the load center with these transmission lines. Basically, the transmission line consists of conductors, insulators, and supporters. The typical transmission line will looks like this. So as we see, the number of towers which are nearby the roads. So transmission line will contains tower, so which is supported by cross arms. Towers, cross arms are supported by the towers, and cross arms are handling the insulators. Insulators are carrying or supporting the conductors. So if it is a single line, we will see a single conductor. If it is a double line, we will see a double conductor. So for double conductors, there are extra equipment called spacers, which will divide the lines, and we will see the dampers, which will eliminate the oscillations in the system, and earth wire, which is located at the top here it is. So at the top of the transmission line, and this earth wire will protect the total structure with the external disasters. Means if it is a thunderstorm, or if it is a thunder, then it will protect, like it is like a lightning arrestor, so which will collect the power from the thunder and it will neutralize the supply, so that our structure will not be disturbed. So I said conductors are used to transmit the power from generating station to load centers or distribution centers. So it is made up of basically it is made up of aluminum. So because aluminum is a cheapest metal, so we are choosing aluminum as a conductor, and we are going for ACSR to strengthen the aluminum. So means it is like a bundled conductor. So where the center part will be steel and surrounded by a aluminum conductors. Next, insulators. Insulators will play a major role in electrical engineering, because without insulators, nothing will happen. So to protect the live conductor, which is carrying power, so separate, and it will not touch with any other metallic parts. So we need insulators. So insulators are made up of porcelain or glass or any semiconductor devices. Any insulating devices. Next, the tower. Tower is the structure which we are seeing. So tower will support insulators, conductors, and cross arms. So tower is a major device. If there is a there is no proper construction of tower, the system will be collapsed. So we have to take care about the tower. So which is, and the tower is made up of it is made up of steel, and it will be protected with corrosion. So we are painting. We are going to paint the tower. Next, cross arm. So because we have to separate the conductor with the tower. So there is a projection from the tower to some extent. So it is called cross arm. So as we seen in the previous diagram, the cross arm is projected from the tower. And finally, the earth wire will be used for the protecting wire, so which is located on the top of your tower, so which will protect your tower from the thunders. Actually, the typical AC power scheme or single line diagram of power system will be looks like this. So it is having a generating station, primary transmission, secondary transmission, primary distribution, secondary distribution. So generating station maximum it will generate 6.6 kV or 11 kV, and that 11 kV has to send to the consumer end with the help of transmission lines. So what we are going to do is we are stepping up the voltage of 11 kV to 132 kV, and further it is 220 or 440, and we are transmitting the power to consumer end with the help of primary transmission. So primary transmission, before primary transmission, we are having a step-up transformer which will step up your voltage from 11 kV to 132 kV. After primary transmission, so at regular intervals, we are maintaining the substations. So this primary, before the primary transmission, so there is a transformer, as we are seeing, it is 11 by 132 kV, which is located in generating station. So after that, we are transmitting that voltage to the next level. So it is where we are going to step down the voltage from 132 kV to 33 kV. So 33 kV will be stepped down at receiving substation, and it is transmitted to the next level with the help of secondary transmission. So secondary transmission, we will have a transformer of step down transformer. So where we are going to step down the 33 kV to 11 kV, and we are stepping down that voltage and sending to primary distribution. So as I said, there are regular intervals of substations, and the primary substation will be maintained by Transco, and the secondary substations will be maintained by DISCOMs, distribution substations, DISCOMs, distribution companies. So after that, 11 kV is further stepped down to 440 or 230. So depending upon the consumer's requirement. So generally, at a primary end, at a primary transmission, it is a delta delta transmission, and the secondary transmission it is a delta delta. But whereas the distribution end, we are going to have a transformer of delta to star, because we need neutral wire at distribution end, because at the distribution end it is not necessary to have a balanced load. So we are balancing the load with the help of neutral wire. So as I said, generating station will generate will generate power with the help of three-phase alternator, and it is generating a voltage of 6.6 kV or 11 kV. Then stepped up to 132 kV or 110 kV or 220 kV or 400 kV. Next, the primary transmission. Primary transmission will have a very high voltage, because we need to transmit the voltage from here to the far distance. So we are going to carry a voltage of 132 kV and stepping down to 110 kV. So generally this substation will be located far away from the cities, and the voltage, the transmission voltage will be determined by considering economical conditions and amount of power to be transmitted and length of the transmission line. Next, secondary transmission. Here we are converting the secondary voltage with the help of receiving substation. Normally, voltage is stepped down from 132 kV to 33 kV. 132 kV to 32 kV. Next, after secondary transmission, it comes to primary distribution. Primary distribution voltage, here also we are going to step down the voltage. So the step down voltage will be 33 kV to 11 kV. 33 kV to 11 kV. Next, after that, the secondary distribution, where the voltage is further stepped down to 11 kV to 440 or 230 and feedback to the consumer. So where we are located, so we are treated as consumers, and this the power quality problem will not arise at consumer point of view, because you need a good quality of power.